smart grids. So before I jump right into smart grids, let me introduce the driving force and the motivation for smart grids. On the 18th of August this year, ABC announced that a new carbon target is set to reduce greenhouse gases emission in Australia by 26% by 2030. But how do we achieve that? But after a few days, it was also revealed that a $350 million investment was made by ARENA and CEFC on solar power plants. These two announcements are actions to reduce CO2, which is also the purpose on implementing smart grids. Generally, power plants need to generate an extra 10 to 15% of power during peak period. However, the use of fossil fuels to generate power will only increase the emission of CO2. But if smart grids are implemented, we can accurately measure the usage and generate power accordingly. Also, extra power generated during off-peak can be saved for emergencies. Motivation towards smart grids includes population and demand, global climate change, energy storage problem, limitations of one-way communication, decrease in fossil fuel, and resilience problem. Now let's look at how does the smart grid operates.
Our current electric grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener.
So what is smart grid? It is basically a digital technology that allows two-way communication between customers and the utility. It consists of things like computers, controls, and is also available to sense along transmission line and automatically respond digitally to our quick-changing electrical needs. It is also a smart grid centered grid operation, self-healing grid used to control transmission system and also used to prevent and handle blackout. Now let's look at how the grids are controlled.
The power being used right now was generated less than a second ago, many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption. The grid was conceived more than 100 years ago when electricity needs were simple. Power generation was localized and built around communities. Most homes had only small energy demands, such as a few light bulbs and a radio. The grid was designed for utilities to deliver electricity to consumers' homes and then bill them once a month. This limited one-way interaction makes it difficult for the grid to respond to the ever-changing and rising energy demands of the 21st century. The smart grid introduces a two-way dialogue where electricity and information can be exchanged between the utility and its customers. It's a developing network of communications, controls, computers, automation, and new technologies and tools working together to make the grid more efficient, more reliable, more secure, and greener.
So what is smart grid? It is basically a digital technology that allows two-way communication between customers and the utility. It consists of things like computers, controls, and is also available to sense along transmission line and automatically respond digitally to our quick-changing electrical needs. It is also a smart grid centered grid operation, self-healing grid used to control transmission system and also used to prevent and handle blackout. Now let's look at how the grids are controlled.
The power being used right now was generated less than a second ago, many miles away. At each instance, the amount of electricity generated must equal the consumption across the entire grid. Smart grid technologies provide detailed information that enables grid operators to see and manage electricity consumption in real time. This greater insight and control reduces outages and lowers the need for peak power. In control rooms across the grid, engineers will be able to more precisely and predictably manage electricity production. reducing the need to fire up costly secondary power plants.
Smart meters. Smart meters is an electronic device that records consumption of electricity in intervals of an hour or maybe less, and report them back to the utility for monitoring and billing purposes. It is enabled with two-way communication between us customers and the central system. It means that consumers will be able to know their real-time energy usage. Since it can provide up-to-date information on our energy consumption, it allows us to manage and reduce our energy and usage bills. Time of use programs. This generally means putting a power meter in our home to bill us differently depending on our usage and time of the day. The time of use program allows the customer to defer non-essential energy consumption to times when demand for energy is lower. This program can control consumption will be less than before. This program will help customers save money by using safe off-peak energy on peak period. With this method, blackouts can be handled by having stored energy from off-peak period sent to area where there is a blackout. Next, I'll pass it to Jose to continue.
The use of communication is really important in smart grids because it's necessary to manage and control power and other data. As the whole system is operating in real time, we can monitor the power flux and of each residence and the utilities as well. You can increase the whole efficiency of the system as well, for example, in terms of reliability. And also you can have a rapid response of technical issues. For example, if you have a fault in the system, how can we redirect the network to supply the clients again as soon as possible, as faster as possible. And talking about type of communication, I would like to talk about wired first. That's expensivest one because you need to use it across the whole system, but you not have interference because the wires are very well isolated. It is more reliable and you don't need to use batteries for that. In the other hand, we have wireless systems that you can have a low cost of infrastructure investment. It is easy for unreachable areas, for example mountains. If you need to make a communication between two utilities systems, and you can put it they are between an isolated area. In terms of communication technology, I would like to talk about Zigbee, wireless mesh, and cellular network for wireless systems. And for wired, you can have a power line communication and digital subscriber lines. For instance, here we have a wireless mesh, and you have different poles, and they are connected between wireless system, and they are using antennas to communicate between themselves using radio frequency. I would like to talk about self-healing now. What is that? As I'm going to show in the next video. If any sudden problem occurs on the system that the clients become without power, how the system will respond to that? How the system will redirect the network to provide supply for the clients as shorter as possible. I would like to show it in the next video.
The distribution system routes power from the utility and commercial customers through power lines, switches, and transformers. Utilities typically rely on complex power distribution schemes and manual switching to keep power flowing to their customers. Any break in this system caused by storms, bad weather, or sudden changes in electricity demand can lead to outages. The smart grid's distribution intelligence counters these energy fluctuations and outages by automatically identifying problems, then rerouting and restoring power delivery. Utilities can further use distribution intelligence to predict and manage electricity usage with the cooperation of their customers, leading to lower production costs.
As a smart grid is an interconnected system using communication systems, there are some requirements that you need to know. The first one is cyber attack. As a network, we should use a very reliable system because we are dealing with $1 million in client satisfactions, and if there is some problem related with cyber attacks, these industries could face many problems. In terms of scalability, it's necessary to plan very well the area that you are going to apply that, because every time the client's consumption during the day is changing, and also there are many new clients over the system, and it is necessary to dimensionate it very well. And the most important thing that we are reducing the pressure over the earth, because we are making management of energy, reducing the energy consumption by the time, saving money and reducing the pressure over the earth. Thank you, everyone. We are open to any question now.
What's fantastic, one thing about this group, I tell you for your future, in I don't know, any presentations in a workplace or something, when they say you need to make a PowerPoint presentation, the idea is not reading from the screen. This is not it. Okay? What you have on the screen should be bullet points. You are the speaker. Bullet points, other than that, you just put it, everyone can read it. It's not like you read it from the screen, okay? It's not like it, right? You have to put the bullet points and talk. But you may have something in here for yourself. We call it prompt, okay? Again, if you just continuously look at the prompt, again, you are losing not in this class, but I'm telling you in general, right? But if you just talk, something like that, you may have seen in TV shows or something, huh? Someone has got something in his clothes or jacket or something. Yeah, no. Yeah, by the way, I just want to talk. Yeah, it's not like it's not like that, huh? Or it's not reading from the book. You have to talk, huh? You need to have a good impression. One thing these guys added was the video was very good, and you referred to very, very important things. One question I've got for your team is, what is ZigBee?
ZigBee is, let's... we were expecting that ZigBee is we were expecting that because we didn't have enough time to talk about. But ZigBee essentially is one device that you can use. That's a wireless device that you can interconnect all of them and make self-communication. You can create a wireless network between them. It is very cheap. However,
is that different from microwave?
I need to analyze it. It follows the IEEE
so you don't
standard.
know the details of it?
Yeah, we just
deeper details not.
Okay. What is the meaning of cyber attack?
Someone can go inside of the system and change the configurations.
So how can you stop them?
Reliability.
How? What is the name of the technique? Starting with the letter E. Yes? Encryption. So you just encrypt the data. Means you encode, you encode something, okay? And then you just get the information back, right? So these are the things that are part of the power system protection. Any question from the group? You're group 4, is that right?
Yeah. Yes.
No question. Maximum 8 points.
Thank you.
Group 5.
It used to be. Sorry. Yeah.